Thank you for your patience. We will now begin advancing clean hydrogen and technologies. And I would like to introduce our moderators and speakers for this session. For our moderators, we have Professor Dr. Georg Erpin, retired Chair of Energy Systems, Faculty of Process Engineering, Berlin University of Technology, President of the Board, Berlin, Germany. Ms. Chen-Hua Wu, ICEF Steering Committee, China Asia Director, Office of Jeremy Rifkin, Chair, Governing Council, Asia Pacific Water Forum, United States of America, China. Professor Dr. Nebojša Nakičanović, ICEF Steering Committee, Vice Chair of the Group of Chief Scientific Advisors to the European Commission, Honorary and Emeritus Scholar, International Institute for Applied System Analysis, Emeritus Professor of Energy Economics, Vienna University of Technology, Austria, Serbia. And for our speakers, we have Dr. Irmela Kofler, Head of Research Area, Decarbonisation, K1Med GmbH, Austria. Ms. Petra Schwager, Chief of the Climate and Technology Partnership Division, UNIDO, Austria. Mr. Ajay Shin, Senior Executive Advisor, Mitsui OSK Lines, Japan. And Dr. HARA Daishu, Senior Director of the Hydrogen and Ammonia Department, New Energy and Industrial Technology Development Organization, Japan. And I'd like to ask my moderator, Professor Dr. Erpin, to moderate this session. So, Professor Dr. Erpin, please take the floor.
Thank you very much. Welcome to this session on hydrogen demand side. The hydrogen discussion is some 50 years old, and I have seen in the last 50 years 3 hypes. The first one, 1980, when the discussion was we have to replace natural oil, crude oil, and hydrogen was regarded as an alternative. After the collapse of the oil price, the discussion of hydrogen collapsed also. In the year 2000 around, there was another discussion. The idea behind was to make individual road traffic clean. That means the local air pollution was crucial, and the car industry wanted to get rid of this, and there was an alternative battery or fuel cells, and there had been in Japan, in Germany, in other countries, very good fuel cell activities. Again, this created a hype on hydrogen, but it collapsed. And now we are in a third hype, which is motivated by the long-term energy storage. Hydrogen is regarded as one option for storing electricity over more than a week or 2 months. But of course, the reason why in the last years we collapsed always, there must be a discussion about the supply and demand. We cannot only look from one side of the market, we have to look both sides. And looking at the ICEF meetings of the last year, we had only discussed up to now the supply side. And today we want to discuss the demand side of hydrogen. And for this, we will have 2 examples for, 3 examples for hydrogen demand. And our last speaker will give a wrap up about the general picture of the development of the hydrogen market. So this is the general idea. We will discuss these 3 cases and then have a general discussion. And my colleagues, my collaborators for the chair, they will ask questions and we will have a discussion. So let us start with our first speaker, which is Dr. Irmela Kofler from Austria, from the Austrian steel industry.
Good morning from Austria and good afternoon to Japan. Thank you for the kind introduction. K1Med is a metallurgical competence center. We have 3 different research areas. Area 1 focusing on metallurgical process efficiency and circularity. I just see myself, so just a question, can you see my slides?
Not yet, but I hope, yes, now we can see.
Thank you. Okay, so this makes it a little bit easier. So the first area, like I mentioned, focusing on metallurgical process efficiency and circularity, meaning that existing processes are being optimized and side products like slags, ashes are being recycled. The second research area where I'm the head of is decarbonization and sector coupling, where we concentrate on two different main topics: carbon direct avoidance, using hydrogen as alternative energy carrier, and reducing agent, as well as carbon capture and utilization, transforming unavoidable CO2 emissions into valuable processes. And the third area is simulation and data analysis, using simulation and modeling to optimize these energy intensive processes in a cost and time efficient way. Next slide, please. At the moment, 70% of the steel production is produced via the blast furnace basic oxygen furnace route. This route is responsible for 7% of the global CO2 emissions. Transforming these processes into the direct reduction electric arc furnace route using natural gas as reducing agent, it has the potential to reduce 35% of the CO2 emissions. And using hydrogen instead of the natural gas, even the potential to reduce the CO2 emissions up to 80%. But the challenge is that for the direct reduction electric arc furnace route, you need high-grade iron ore as raw material. And that's why we at K1Met focus on different technologies to produce steel. Next slide, please. And one of these technologies I want to introduce to you is the hydrogen plasma smelting reduction process. In this process, we use hydrogen plasma. It's the ionized hydrogen state, the most reactive state of hydrogen. And with this process, iron ore can directly be processed into liquid steel in one single step. At the moment, it's a fundamental research project with a capacity of 100 kilograms per batch, and we want to optimize it and to upgrade it next year to a semi-continuous process with a capacity of 200 kilograms per hour. Next slide, please. And the second technology I want to introduce to you is the HYFOR process, the hydrogen-based fine ore reduction. It's a process where the hydrogen is used within a fluidized state, and the iron ore is processed into direct reduced material, but with hydrogen, and not with natural gas. On the slide, you can see a batch reactor with 800 kilogram capacity, and in 2027, a demonstration plant will be commissioned with a capacity of 3 tons per hour. So, and after this, the product can be fed to an electric arc furnace or to a smelter to be processed into crude steel. Next slide, please. And in the beginning of my presentation, I also mentioned carbon capture and utilization as CO2 emission potential. And on this slide, you can see an amine scrubber to capture CO2. And this CO2 we transform into via catalytic methanation into methane, for example, to close a carbon cycle and thus reducing the CO2 emissions. Thank you very much.
Thank you, Irma. Next speaker is Petra Schwager.
Thank you very much for giving me the floor. Could I have the slide, please? Can everybody see it? Yes. Very quick introduction, and apologies to those who are well familiar with my organization. I represent United Nations Industrial Development Organization that has its headquarters in Vienna. And our mandate is aligned with SDG 9, which is actually sustainable industrial development and promoting it as a means to fight poverty. We have three big pillars of work. One is climate, fighting hunger, and sustainable supply chains. So with this, we initiated some 4 years ago our global program for hydrogen in industry, with the aim already to drive a new industrial development, not just to look into the production itself and to export, but to look into local application of hydrogen. Here you see our donors and the countries where we are at the moment active, and I would say from the UN agencies, we are the lead agency on hydrogen. From the beginning, we were looking into, as I mentioned, local application, but we're also supporting sustainable international trade. We are, for example, the Secretariat of the International Hydrogen Trade Forum, where we are bringing together 19 countries by now, and where there's a debate ongoing from importing and exporting countries. What are the enablers? What is needed for a global sustainable hydrogen economy? And in addition to this, or for this, we need policies, we need standards. We have a very close cooperation with ISO on a new low emissions hydrogen standard that will come into place next year, most likely. We work also on sustainability because hydrogen needs a lot of water. Hydrogen is very often operated in countries where this is not the case. So how do you use this water? How do you make good use of the land? And how do you create additional value added for the surrounding population? So this is very important. And this is not just important for hydrogen, this is important for every energy project. You need the agreement, and you need to create value from the surrounding population. We do also have put big emphasis on innovation, because one of the big factors at the moment is, of course, the demand, but the demand is driven by costs very often. So if we manage to bring the costs down, and in my humble point of view, I think one of the most important technologies will be more energy efficient electrolyzers and less water use in the future of hydrogen, because 70% of hydrogen, renewable hydrogen, is due to the renewable energy costs. This is also why they are located very often in areas where you have low renewable energy costs. Let me just come back a bit on what you also said, Georg, on the hype. We see a switch from the hype to reality and to implementation. So here is a bit of an overview. We have at the moment 510 projects committed to FID globally. We have an increase of 83 projects since last year, and an increase in installed and planned electrolyzer capacity. So there is room for hope, and I think there is a more realistic target now, and also a diversification of the demand. So not just on transportation, but we're looking into industry, and it's also a main factor for food production, which I will just talk about now. Here you see a bit how the production is distributed. What I would like to bring to the table now is an upscaling of hydrogen demand through fertilizer production. As I mentioned at the beginning, we look into local application and production. At the moment, a fertilizer produced from ammonia emit 2.5% of global emissions. We have a very, the supply is very much located in a few countries, and that creates a lot of insecurity in food. We have big opportunities. Ammonia from green hydrogen can be used to fertilizer production. We can decentralize fertilizer production, and we could upscale industrial development potential. But the challenge again, how to distribute the green premium, the price and the cost of the hydrogen. And here we are working along the hydrogen supply chain. I will come back to this earlier, not to take too much time here at the beginning. Just have a look at the situation in Africa. We have fertilizer increase 4% by cost through to transportation. We have an underutilization underuse of fertilizers there, and a lot of dependence from imports. So what we are bringing to the table and what will be the focus of our work this year would be work on demand signals, lead market creation, and feasibility of localization. And if you want to read more, we have just recently published also an article in Brussels Time. Sorry for being very fast here, but I think my time is over, and I'm happy to take questions. Thank you.
Thank you very much. Our third speaker is Ajay Singh.
Thank you very much. So I work for shipping. Shosen Mitsui, OSK Lines, MOL, we are the world's largest private operator of ships. So in the fleet, we have something around 900 plus vessels. The total number of commercial vessels in the world, above 5,000 gross tons weight, is about 100,000. So we are about 1% of the global fleet. So what that tells you is that it's a highly fragmented industry. So the first point there is the challenge of actually ensuring decarbonization across a very large, globally dispersed fleet, many different nationalities, and all sizes of players. Somebody with a single ship is also a shipping company sometimes, just as we are. And the largest shipping company in the world, the Chinese state-owned company, is over 1,000 vessels. Shipping is hard to abate for various reasons. First and most important is the compromise we have always to make between how much fuel we carry and how much cargo, how much payload we carry. So the fuel source of necessity has to be a high-density source of energy. This is the reason why it is difficult to electrify shipping. Coastal shipping can be electrified, and we have, through our joint ventures and subsidiaries in Japan, for instance, vessels which are operating with electrical power as pilots for the future for coastal applications. But for ocean-going ships, it is very difficult to electrify. So we need a source of fuel which is compact and which is high energy and which can be burnt in engines. The good news is that the engines are available. Regulatory processes to certify them on new potential fuels like ammonia are still ongoing. But the technology is not too difficult, and the engines are available potentially. The bad news is the fuel is not available. So wherever we go, we could deploy zero-emission vessels on the sea fairly soon, but the fuel has to be there. And when a ship, you can imagine it's a global network, so the fuel has to be available all over the world at the price which our charterers, our customers can afford. The other key point to mention about shipping is that the fuel choice is not entirely up to the ship owner, that's ourselves. There are three parties involved. In addition to the fuel supplier and the ship owner, you also have the user of the ships, because the fuel cost is a major component of the shipping cost, and therefore it's a three-way dialogue, and we need to bring our customers on board. And we are undertaking a number of initiatives to try and actually have this three-way conversation. And we are cautiously optimistic. Later this month, in fact, next week, there is going to be a very important meeting of the International Maritime Organization, the IMO. They've been very progressive. Over the last several years, they've been working on a decarbonization framework. So this net zero framework of the IMO was actually internally agreed in April, and next week it's going to be put to the vote. So the IMO is an organization belonging to the United Nations umbrella. It's an intergovernmental organization. As a shipping company, we give our inputs to the Japanese government, who then represent the Japanese national view, and they've done a very good job of that. Regulation will be extremely important in order to ensuring decarbonization. And if it happens, if the vote is passed, then what you will have is in place a framework which has a force of law applicable internationally, whereby ship owners have to achieve certain levels of decarbonization progressively. There are targets for the next 5, 10, 15 years, all the way up to achieving net zero by 2050. The other reason why that is significant, even outside of shipping, is because we are an industry who unify the supply chains. So just a simple example, in our case itself, we carry the raw materials and the fuels necessary for, say, steel making. We then carry the steel to various industries like auto production, and then we carry the automobiles to the end markets. So we are also in a position to try and act as sort of catalysts of the further decarbonization beyond our own individual sector. Before I came to work for MOL 5 years ago, and I came to Japan 11 years ago, my career has been mostly in the oil and gas industry. I worked for Shell for almost 20 years. In fact, Mr. Vikram Mehta in the audience there is my former senior colleague and boss. I worked with Shell for 20 years and for a Japanese state-owned oil company for 6 years. And I would just like to conclude by making one final point, is in the oil and gas industry, the number one rule we were taught is that if you want to develop gas supply of any sort, say natural gas, it's applicable to hydrogen also, you have to have a readily available, bankable market to ensure the revenue stream for the large capital investment you have to make in the production. So I think the point you made in the beginning about market development is absolutely fundamental, and we need to, I'll be happy to talk during the discussion on how we can try and make that happen even outside of shipping. I'll stop at this stage with that. Thank you.
Thank you. Our fourth speaker is Daishu HARA. Son.
Yeah. Thank you so much for the introduction, kind introduction on me. Well, as the moderator introduced me, I'm Daishu HARA from NEDO, Japan. I'm really honored to be here together with the distinguished moderators and the other panelists. And also, I sincerely appreciate to the many of the organizers of this event for giving me the opportunity to be here. Well, I think during the past 2 days of the discussions, most of all you have already understanding our organization's functions in Japan and also our activities regarding the hydrogen. So I will not explain the details of our activities right now, but I will explain in the following sessions of the discussions. But anyway, personally, sorry. I have been working in NEDO for more than 20 years, involving with a variety of the electrochemistry relating the national project, such as the hydrogen or the batteries, and so on. And also, I conducted many of the international programs all over the world, especially in the ASEAN and also the Americas. As a staff of the overseas offices in all over each regions. So, but now I'm the I'm a member of the hydrogen and ammonia department of NEDO, and that department is the promoting of many of the hydrogen-related programs as well as the ammonia, from the basic research level to large-scale demonstration level for the dissemination of for establishing the whole-scale hydrogen value chain. But anyway, I hope that this discussion will help us to understand or to share the past knowledge of our activities, and hope to have we can have the wider collaborations. We can have the wider possibilities of the collaboration to each other. Thank you so much.
Thank you. Xanu, you want to ask the first question?
Sure. Thank you, Chair. Thank you for all the speakers, panelists, sharing your insights. I have a couple of specific questions there. Firstly, it's really about maybe focusing on the steel industry. In my professional life, I used to sit on the Sustainability Advisory Board of BHP. And at least for 5 or 6 years, this sort of hydrogen, steel, really being up there on the agenda whenever we convened there. So today is still demonstration. In many cases, actually, still large. I think, HARA-san, you mentioned the large demonstrations even there, but still, we're not really getting to where we should be. I know you mentioned a lot of costs, different reasons, stuff like that. I do want to get a little bit more clarity from you all in terms of technologies are here already. We've been trying them out and even piloting, industries are piloting there. give me roughly a timeline, right? Now we have NDCs for 2035, we're getting to 2030, getting into the next NDC there. So roughly we have this sort of next 5 to 10 years, which will be critical for us actually to address this issue. So we do need to get to the scaled deployment part. So my question is, so what's your perspective view about when we'll get over to the next stage, and what are the conditions actually will be really absolutely required in order to do so? Thank you.
Yeah, I would say, Irmela, can you answer this question? Irmela.
Yes, of course. I mentioned that it's an important topic regarding this is the quality of the produced steel grades. We focus on hydrogen-based steel production because in Austria and in Europe, but also globally, it is important to produce high-quality steel grades, and it's also important to produce them out of low-grade iron ores, because high-grade iron ores are not that available than low-grade iron ores. And for these products and for these raw materials, hydrogen is essential, but the timeline is that these processes will be developed within the next 10 to 15 years. So the hydrogen demand will be up to 2035. And of course, it's always the chicken egg problem. We need a stable hydrogen supply to invest in these new processes, because of course it's a risk to change a technology. Is not just to transform from gray hydrogen to green hydrogen. It's a completely new process chain, and this contains risk, and with risk, of course, all the side consequences must be secured, and one of these conditions is the stable hydrogen supply.
Thank you. I think, Hara-san, you will have also an answer to the state of the technology, steel-making technology based on hydrogen.
Yeah, thank you so much for having a question. Well, in our case, we are conducting the steel-making project with the hydrogen, and until now we are conducting the project until the 2030. And then after completion of the technology itself, and we are aiming to the alternative target of our activity is getting the 50% of the reduction of the CO2, but how to say? Right now, I cannot say how to say when we can complete that, achieve that the value right now. But we are now trying to until the 2050. Yeah. Thanks.
Thank you very much. I think the other two technologies, fertilizing and chip industry, as I have understood, these technologies exist. We have only applied them. I am right?
Absolutely correct. I mean, nowadays, ammonia is already the main ingredient of fertilizer production. So if you have an existing gray ammonia production, you can switch to green ammonia production or renewable hydrogen-based ammonia production or clean hydrogen-based ammonia production rather fast. What you will have to have in place is eventually already the fertilizer production capacities. So that can be done rather fast, and this is also why we feel that this will be a focus for us this year. We are talking about lead markets that can create the demand, which then will also trigger more hydrogen production and bring the costs down.
And then the ship business.
So if you look purely at the technology, yes, it's available. But I think, once again, I'd like to just touch upon the timelines and the challenge there. So if the IMO's proposals are voted in, what they want to do is the targets will be that each ship has to reduce emissions by at least 20%, if possible 30% by the end of the decade, and go to 40% reduction, 70 to 80% reduction, 70 to 80% less carbon emission by 2040, and net zero by 2050. Now, we had set a target internally, which is still our target, is 130 ships, net zero vessels on the oceans by 2035. This target was set many years ago, well before the IMO developed its proposals, and we'd still like to try and meet them. Now, if I have to have 130 ocean-going ships, that's roughly 15% of my fleet in a decade, I need to start taking investment decisions yesterday, because it takes 2 to 3 years to build those ships. And I can't do that because I don't even have a reasonable price estimate or guarantee of availability of the fuel from any fuel supplier anywhere in the world. So that's a bigger challenge. Secondly, if you say ammonia could be a solution, the total size of the global fuel, the fuel volume needed by shipping today is about 300 million tons per year, all, mainly hydrocarbons, oil. And the total amount of ammonia production in the world today, none of which is clean, by the way. This is all gray ammonia, which emits loads of CO2. The total size of the ammonia industry is about 200 million tons per year. While shipping alone is consuming 300 MTPA of hydrocarbons. Now, if you look at that, you can draw your own conclusions about the feasibility. So rather than technology, I think it's what it will take to get the system going. There's also the social aspect. Some of these fuels, ammonia has been used before, but it is a toxic gas, and there will be a degree of social resistance to its adoption. Yes. So these are all the challenges which we have to start working towards. So I don't want to paint a pessimistic picture at all. I think we have to start somewhere and really put all our effort into it. But these are the sort of challenges, and it's important to remember them so that we don't face early disappointment. This will require perseverance, it will require resilience and commitment. And it will, of course, require a lot of support from governments and regulators to make sure that people stay the course.
Okay.
Can I quickly just ask another follow-up? I do want to bring the China part actually into the conversation. And Petra, you mentioned this 110 project registered or whatever. Somehow the number I read from China saying, China's supplying capability manufacturing probably will take over 60% of the global capacity already. So the conversation within the country is about overcapacity. So just to give you a little bit of sort of different perspective when you put China in the global context there. So my question, particularly for you, Petra, so what do you see, China's role in this is put in the context of collaboration in advancing the hydrogen revolution, and what does it take actually for China to be a more constructive participant actually in the global process? Thank you.
Thank you.
Naki, do you want to say something?
Well, maybe after this question.
Okay. Good. The next topic we should discuss is political. Sorry.
Can I answer? I think that was a question, though. Yes, indeed. We have an International Hydrogen Energy Center, which is actually a close cooperation with the government of Beijing. And we are quite familiar what is happening in China. And China will be one of these countries that will use hydrogen inside and eventually also export. What we have seen in the collaboration with China, and this is really a good example on long-term planning. And now you mentioned in the break before the next 5 years plan, so you know what is coming, and this is what is driving a lot of insecurity. And what we also heard from the shipping oils: if you don't know when the ammonia will come, if you don't know when this will come, if you don't know how much you can expect, it's very difficult for investors to plan. So this is really something that we can learn there. But what we are also trying with China is this is a very good innovation center. So we are bringing our partners from the countries we are working to China, and they were very impressed on what is happening in innovation there, what is happening on fuel cells. And many of them have already requested us to replicate this model in other countries. So that is a very good, example on how we can stimulate this global cooperation. If I may, just one point on the fertilizers before, and I don't want to take the floor too long. But on the demand side, on one side, what Steel is doing now is the IMO, that we have a commitment to uptake ammonia is important. But there's also this green premium, and what we see, for example, with HARA, which is one of the biggest fertilizer producer. There's a case in Latin America with local potato producers. So then they can sell eventually their products as low ammonia based or low carbon products. So if we could bring in the whole supply chain, I think the demand will also increase for some of the products.
Yes. Yeah, my question is actually quite related to this very interesting discussion, by the way. I think we have the challenge of timing or the time horizon, and I think implicitly you all said that. I mean, if you think about it, hydrogen is about, renewable hydrogen might be 2 or 3 times more expensive than the natural gas hydrogen, so it's a tall order to take over. And so I would imagine, since we're talking about the demand, that we need to attack those sectors that are very difficult to decarbonize. And I think this is what you talked about. But that takes time. For example, if one looks historically, basic oxygen took decades to diffuse. And I think we will have that with many of those technologies. So I just wondered whether you can comment, what do we need to have this long-term commitment that actually the investment will flow? And that in itself, would create a demand pool for the technologies to diffuse, develop, and hopefully for the prices to go down. So how do you see that? Well, what do you think would be required?
May I take that? So I think the first thing I would, there's a number of things, but the great is the enemy of the good, yeah? So the famous old saying. And I think we have to be very pragmatic and strategic in how we look at the cost reduction, because that's absolutely, you've hit the nail on the head. It's the most important issue. And to quickly scale up, I have 2 comments. So number 1 is building the market. Don't forget the small niche applications where it's possible for hydrogen to be cost competitive today. Don't attempt just doing very fancy billion-dollar international ammonia export projects. Those are important. We should do them. But equally important is small industrial applications where you can produce and use the hydrogen locally, because you immediately cut out the whole business of processing, conversion to liquid hydrogen or ammonia, et cetera, et cetera. So short supply chains within a 100-kilometer radius of the production point, and there's a number of things we can do. A lot of applicability into logistics, into industrial processing as a material, specialized manufacturing. So those small individual initiatives, they're also very financeable, because you're not going to make a lot of profit. Sometimes you may not make any profit at all. In this country, Iwatani, the gas distributor, they developed, I think, 100+ hydrogen refueling stations over the last several years at a no profit, no loss basis, more or less. I mean, I don't know if they would like me to say this publicly, but essentially it was a byproduct of the Japanese space program where they were making liquid hydrogen for the rockets. And out of their commitment to hydrogen, they developed a whole network of hydrogen stations. So you need that sort of an effort, because that does represent a bit of a ready market today. If Japan had low-cost local production of hydrogen, as India and China could and already do to some extent, that could have gone into that ready market. So the small-scale market development. And secondly, I think China, India, these are 2 very vital countries for hydrogen. And China has done an enormous amount of work already on commercializing domestically. India would do that. And if you look at other key geographies who are majorly dependent on some sort of a fossil fuel or even imports, where you can commercialize, Indonesia, South Africa, countries like that. So I think we need to identify those and collaborate and get the costs down. If I may take just one more minute, the numbers. So $1 per kilogram is what we need to put hydrogen into power generation to beat natural gas. And $4 a kilo is what we need to beat liquid fuels like petrol and diesel in China, India, or Japan. In India, and I'm sure in China they're even ahead of this, is you can get hydrogen production, green hydrogen production at gigawatt scale today, based on the projects which are claimed to be taking FID now, at under $4 a kilo. And maybe compression costs have to be added if you want to put that into automobiles, but we're not that far off. Ammonia, we've had FIDs on projects at $600 per ton. And that's considered a pretty good price for ammonia. from green ammonia in China and in India. So I think on the cost picture, just as a framework, I think we're getting closer to where we need to be eventually.
Thank you very much for this very enlightening comment and also the strategic orientation. I worked in a project with Daimler, this NECA, this fuel cell product, and the boss of this project from the Daimler side said, what we need is rich and curious customers, because they pay a little bit more than the normal market, and this will allow the company to cover some of the development costs. So that is, I think, the similar idea to get niche markets which can be, where you can earn a little bit more than on the mass market. I think we should shift the topic now. We should shift to the question subsidies and state support for. I would start my question with one observation, again from the German side. I've seen a lot of projects. The government sponsored maybe 20 million euros for developing a fuel cell project or electrolyzer. And after this money was over, then the developer closed this factory. So it was no idea to develop a sustainable market. That means the money that the government spent was somehow for nothing. And the question is, if we ask for government support, we should give the government an idea what you should do in order to create a sustainable market, not only a short project which after 2 weeks is over. Maybe we go through our speakers and maybe we find an answer to this problem. First, Irmela.
Thank you. Yeah, I think it's all about the question, do we take the net zero emissions goals serious or not? And then we need the right framework conditions for that. And of course, it's not sustainable to run electrolyzers, for example, only with subsidies in a economic way. And it's more important that the customers, that they are ready to pay for green products. And if they are ready to pay for it, then also green hydrogen production will be economical. And in Austria, we operate the H2Future plant, the 6 megawatt PEM electrolyzer system since 2019. And it's the longest running PEM electrolyzer system, so proton exchange membrane system producing green hydrogen. And it's still running and without subsidies.
Okay. So, Petra?
Well, I think you always need pull and push mechanisms in place, no? And on the pull, I would say really quotas. If you impose quotas, then you will also have a demand, and this is what's now being discussed in the EU quite a lot on these lead markets, being shipping, being also fertilizer production, so that there are quotas. On the other side, I would not underestimate that that it is very important to support startups there through government support, because this will also drive a new development, and as I mentioned before, new technology development and bringing the costs down. So I would argue that this is also very important. Then your government is very active in H2 Global, where they have international auctions, where they subvention the import of hydrogen. So for some time until we get there, I think it's a good mechanism, but you have to see what comes next. So planning over a long time and is essential. And last but not least, we have developed a policy toolkit together with IRENA, International Renewable Energy Agency, to pair industrial development with hydrogen development. And I think that's also very important, that you see where does the country want to go, which industrial development it wants to choose, and where does the hydrogen development come, and how can I put the two together? Thank you.
Well, I don't want to directly talk about subsidies as such. I guess in some cases they are necessary, but I think government action in general, the more focused and thought through it is, it would be better. And just as a simple example for green hydrogen, let's say, enhancing the utilization of electrolyzers is a key point. And in some countries, we see that there's an insistence on 100% renewable power for electrolysis for it to be counted as green hydrogen. I think that is perhaps a little too over the top at the moment, because it's very hard to achieve that. Now, in some countries, they have, for example, at night time, you can transmit surplus wind power free of cost. In India, they have this kind of policy. So you can utilize that subsidy, I think, would be helpful. But we should be pragmatic and allow, say, predominantly renewable power for electrolysis. But if you can do 60% of your electrolysis with clean electricity, there's no harm in allowing the other 40% to be generated from fossil fuels for the next 5, 10, 15 years. Because I think if we can achieve even 50, 60% decarbonization, that's huge. We should go for that instead of insisting on absolutely ultra clean from the word go. So this is what I mean by, the great being the enemy of the good.
Okay, thank you. Now, HARA-san?
Yeah, it's very difficult, and right now I don't have the concrete and short answer, but so that is why we are now struggling from the viewpoint of the standpoint of the governmental agency. Well, so let me briefly explain the Japanese policies and also our NEDO's activities regarding this point, just for the introduction of the just an example. Can I ask you to show the slide, please? Yeah, from the slide 5, please. Can I move? Yeah. Yeah. As you know, Japan started working on the hydrogen about 50 years ago. Well, right after the first oil crisis, and at that time, under the Sunshine project, we conducted the projects such as the water electrolyzers, related to hydrogen storage, and the fuel cells. And later, in 1990s, we launched the UNIDO project to build a global hydrogen network. Since then, Japan has kept developing hydrogen technology step by step. And from now, according to regarding to the policy-related matters, in line with the recent global movement toward decarbonization, it's famous that Japan became the first country in the world to establish the national basic hydrogen strategy in 2017, and later in the sixth strategic energy plan, hydrogen was officially recognized as one of the main national energy resources. Then, in 2023, the hydrogen basic strategy was revised, highlighting the importance of the action in hard-to-abate industries, such as steel and the chemicals. And finally, the most important part, in 2024, Japan enacted the Hydrogen Society Promotion Act. Well, it's very important that this law that officially sets the government support for hydrogen firstly in Japan and also, I think, that in the world. So the private companies can make decisions and investments more confidently. So in any way, through this continuous effort, Japan aims to build a full hydrogen society, just as it once successfully developing energy infrastructure through strong public-private cooperation. Yeah, one more point, let me introduce our activities as a soft approach. We are formulating the technology roadmap on the fuel cells and the water electrolyzers that guides the national R&D prioritized and promote the efficient investment. The most important matter is that the process itself, the process of the formulating the roadmap itself encourage the deep discussions among the industry, the academia, and government, and fosters the innovations. From the viewpoint of the technologies, we think this is very important.
Thank you.
Thank you.
Xinhua, you want to question to this point? Subsidies, no, or state aid. So then we come to the third pillar of our discussion today. It is international cooperation. International cooperation, I think the example of the European Union is this emission trade system, which means that it's an uniform price for CO2, which is assumed to increase over time, and then it creates a signal for the merit order of technologies to abate CO2 emissions. And perhaps hydrogen is somewhere in the middle of this merit order, so maybe not the most expensive, probably not the cheapest way. We have solar energy and wind, which is probably cheaper, but somewhere then you create a chance. Is this an idea of international cooperation, concrete, develop this kind of approach? Yes, maybe. Petra.
Thank you very much, because this is exactly the topic my division is working on at the moment. We have been assigned to look into carbon markets, international carbon markets. And what you mentioned is, of course, a system that works within the EU, but it doesn't work beyond the EU. So we would have to expand it a bit more. The EU is now opening up a bit, but it's only, I think, 2036 that they will accept 3% of carbon reductions outside of the EU to be accounted for the EU. Maybe that will change. But in order to do this, you have to develop a methodology. And you have to develop a methodology for a carbon market, for a carbon offset project. So this is what we are doing at the moment with some partners for hydrogen projects. And to be honest, I believe that this will be could give a big push to hydrogen projects. And India has already put hydrogen on the list of its NDC, so that this would be something they would like to see also with carbon offsets projects. But first, you need the methodology. You need to apply it locally. This is a precondition, and then you have to get the price.
Mm-hmm. I think for Ajay, it's very simple. In each port where your ships arrive must be hydrogen.
Well, hopefully, yes. If I may just point out one very positive development recently, which the Japanese government has enabled, is so in this country, the cost of renewable power is unfortunately very high. It's one of the challenges Japanese manufacturing faces. And they've enabled that Japanese companies investing in decarbonization projects overseas to the extent of more than 15 or 20% of the equity. I don't remember exactly how much. The carbon credits they will generate can count towards their decarbonization targets in Japan. So they can be traded on the Japanese carbon exchange. I think it's a hugely helpful development. And so the point is the international cooperation. I think, of course, we need to count carbon emissions on a national basis. That's a whole COP framework. But let's have such enabling features where you can have decarbonization based on the origin of the investment, the source of investment, because this is ultimately benefiting the global good.
Thank you. Hara-san, I think we are very astonished about the efforts and the continuous stability of the CO2 politics and in particular hydrogen politics of Japan. With this, you want to internationalize your activities? Is this the idea?
Yeah. Well, we have already conducting many of the international collaboration projects, especially for the formulating to try to formulate the worldwide supply chain. I mean, importing the hydrogen from the countries that have plenty of the renewable energies and so on. So, for example, we are doing the large supply chain programs from Australia, importing the liquefied hydrogen with the large tanker in the GI, Green Innovation Programs in Japan. Yeah, that is one example. And also, we are promoting many of the research that contribute to the establishing the standardization. We need to thinking for the adoption of the equipment in the national ordinary level for the students, we need to think about that matters, of course. So we are, through the NEDO's R&D programs, we are, providing many of the results for the based on the scientific base result for establishing that kind of activities, for private sectors. Thank you.
So Changhua, standardization and setting the norms, I think it's an issue in China.
We are all on it, and we all recognize, particularly when China is really demonstrating the stronger leadership, sort of dominating the global clean energy transition, because we have such a large industrial manufacturing sector, sort of landscape there, so standards become a key. And so we even have a 5-year plan this year, at the final year of the 14th 5-year plan. So the government actually made a decision, like by the end of this year, I will check with the number, 85 to 90% of Chinese standards either already aligned with the global, or we are helping or setting global standards there as well. Specific for the hydrogen sort of landscape there, China is well positioned, advantage in many, many ways, because we're already leading renewable energy, solar, wind, so we have a very solid foundation to do that. So absolutely, you can expect China coming on board very strongly to be trying to become a leader setting standards in this sphere. Thank you.
Irmela, do you have things to comment on, something to comment on this international cooperation?
Unfortunately, I'm not an expert in this field, but on general, we need similar conditions worldwide that we can be competitive in Europe.
Thank you very much. So that brings us to the end. I would ask Naki to give a final statement for this session.
Thank you, Georg. As you might imagine, I mean, this was very rich discussion. There's no way I can summarize it, but I can reflect a bit on it. So our objective has been to look how, from my point of view, how to get hydrogen, in particular green hydrogen, out of the niche market through demand policies and sustainable policies on supporting hydrogen. And as you heard from Georg at the beginning, I think, that some of the technologies are now over 50 years old. So the question is not just how to improve them, to reduce the cost, but also how to scale them up and enter them into the market. So from my point of view, and I'm listening to you, I think the way to do this is electrification is clearly going to be the pervasive development in the decarbonization. And I think hydrogen could have a complementary role. And I think this is for sectors that are very difficult to very hard to decarbonize. And we talked about shipping, we talked about steel industry, I would add cement to it, long-distance transport in general on the streets. I think that's also important. And by the way, the first hydrogen aircraft flew already 50 years ago. So, I wouldn't exclude any great innovations in the future. So I think from my take of this discussion, this is the challenge. How to enter those, how to generate the demand in the sectors that are very hard to abate. Now, the problem is that 99% of the hydrogen is still fossil. But in principle, that would not disturb me if it was done with the CCS and carbon was stored. But of course, it's not. So that's the challenge. And then the green, as we said, how to scale it up, bring the cost down, and create reliable demand. So I would imagine, I think we have still a few more seconds, I would imagine that there are 3 things that need to be done. First is rapid scale up for low carbon hydrogen technologies, especially green hydrogen, then development of the infrastructures and markets. To some extent, maybe old pipelines, gas pipelines can be used because hydrogen flows twice as fast at the same pressure. On the other hand, steel is porous to hydrogen, so it's non-trivial. But this is, and then last but not least, the cost gap and the de-risking that we discussed also yesterday. I think some of these investments need to be de-risked. And so my final comment would be, it's a metaphor. If you think that the world is electrifying, in order to avoid the dangerous climate change. We can call that electron. Then hydrogen is a proton, and I think that is a very nice combination for the future, should it work out, a world of electrons and protons to provide energy services. Over to you, Georg.
So thank you with this wonderful discussion. Thank to all the speakers, and so this ends our session.
Thank you, Professor Dr. Erdmann, Ms. Wu, Professor Dr. Nakicenovic, and all the speakers. So this concludes Advancing Clean Hydrogen and Technologies. So I would like to ask all the speakers and moderators to rise. I'd like to send them with a big round of applause. Thank you very much for the outstanding session. Thank you. Please proceed.